October 1944. Ulithi Atoll. A sailor stands on the deck of a damaged destroyer, staring at something he doesn't quite believe is real. It's a dry dock, a massive, floating dry dock, but it's not anchored to any shoreline. It didn't exist here yesterday, and somehow, impossibly, it's big enough to service a battleship. He watches as tugboats maneuver the enormous steel sections into position, watches as they're connected one by one like pieces of a giant puzzle, watches as pumps roar to life and the whole thing settles into the water, ready to lift a 45,000-ton warship like it's nothing. How the hell did they get that here? He asks nobody in particular. The answer is something that still sounds like science fiction. American engineers built a factory that could float across an ocean. They built it in sections so it could be transported. They made it modular so it could be assembled anywhere. And they built dozens of them. The Japanese called it American magic. German naval observers called it the weapon that cannot be sunk. But the U.S. Navy just called it the ABSD Advance Base Sectional Dock, and it changed everything. Let's rewind to 1942. The Pacific War is going badly, really badly. Pearl Harbor's a smoking ruin. The Philippines have fallen. Wake Island's gone. Guam's gone. The Japanese are pushing south toward Australia and east toward Midway. American ships are fighting and dying thousands of miles from the nearest friendly port. When a destroyer takes a torpedo, when a cruiser gets hit by bombs, when a battleship's hull gets torn open, there's nowhere to fix it. The closest major dry dock facilities are in Pearl Harbor if they're even operational, or San Francisco, or San Diego. That means damaged ships have to limp across the Pacific vulnerable, slow praying they don't run into another Japanese fleet. It means weeks out of action, sometimes months. And here's the thing about naval warfare. You can have the best ships, the best weapons, the best sailors in the world. But if your fleet can't stay in the fight, you lose. Japan understood this. Their strategy was built on it. Hit American ships hard enough, far enough from home, and they'd have to withdraw for repairs. Do that enough times, and eventually America would give up the Central Pacific. It almost worked. After the Battle of the Coral Sea in May 1942, the carrier USS Yorktown took serious damage, bomb hits, near misses that buckled her hull plates. She needed months in dry dock, but Midway was coming. Admiral Nimitz needed every carrier he could get. So they did something crazy. They put Yorktown in Pearl Harbor's remaining dry dock and worked around the clock for 3 days. Welding, patching, doing everything that would keep her floating and fighting, even if it wasn't pretty. Yorktown made it to Midway. She fought. She got hit again. And she sank 3 days later. But for those critical hours at Midway, she was there. Her aircraft helped sink 4 Japanese carriers. That's when someone in the Navy's Bureau of Ships had a realization. What if we didn't need to bring the ships back to the dry docks? What if we could bring the dry docks to the ships? The concept was insane. A traditional dry dock is basically a massive concrete basin dug into the shore. You flood it, sail a ship inside, close the gates, pump out the water, and the ship settles onto blocks. Then you can work on the hull. They're permanent structures. They take years to build. They're tied to geography. The U.S. Navy wanted something different. They wanted a dry dock that could float, that could be towed across oceans, that could be assembled in any protected harbor, that could service everything from patrol boats to battleships. Oh, and they wanted it fast, like, we need this yesterday, fast. The Bureau of Ships assembled a team of naval architects and structural engineers. They sat down with a problem that had never been solved before and started sketching. The result was the ABSD Advance Base Sectional Dock. The design was brilliant in its simplicity. Instead of one massive structure, they'd build it in sections. Self-contained pontoon units made of welded steel. Each section would have its own buoyancy tanks, its own pumping systems. You could tow them individually, connect them on site, and suddenly you'd have a dry dock wherever you needed one. The largest version, the ABSD-1 through ABSD-6, consisted of 10 sections each. When assembled, the whole thing was 850 feet long. It could lift 90,000 tons. To put that in perspective, that's big enough to service an Iowa-class battleship with room to spare. Each section was a steel box about 80 feet long, 240 feet wide, and 60 feet deep. Empty, they floated. When you wanted to lift a ship, you flooded the ballast tanks and the whole dock would sink. The ship would float inside. Then you'd pump out the water and the dock would rise, lifting the ship clear of the waterline. Simple in concept, nightmarishly complex in execution. Building these things was its own kind of warfare. The contracts went out in late 1942. Multiple shipyards got involved. Bethlehem Steel, Newport News, Todd Shipyards. They had to fabricate these massive steel sections with precision tolerances. The connecting points had to align perfectly, or the whole system wouldn't work. The welds had to be flawless, or the sections would leak, and they had to do it fast. One engineer who worked on the ABSD-2 sections later described the atmosphere. "We were working 16-hour days, 6 days a week. The Navy kept sending us updates from the Pacific, how many ships were damaged, how long repairs were taking. Every week we were behind schedule was another week American sailors were dying." The first ABSD section started arriving in the Pacific in mid-1943. And here's where it gets interesting, because getting them there was almost as impressive as building them in the first place. Each section weighed hundreds of tons. You couldn't just load them on a cargo ship. They were too big, too heavy, too awkward. So they floated them. Tugboats would tow individual sections across the Pacific. Convoys of floating steel boxes riding low in the water, moving at maybe 5 or 6 knots. The crossings took weeks, sometimes months. Imagine being a tugboat crew on that detail. You're towing a giant steel pontoon through submarine-infested waters. There's no way to zigzag effectively. You're slow, you're vulnerable, and your cargo is literally irreplaceable. One tug captain wrote in his log, "Spent 47 days towing ABSD-3 Section G from San Francisco to Espiritu Santo. Thought about those boys waiting for repairs every single day. If we lost this, people would die. That's a heavy thing to carry." They didn't lose them. Through storms, through submarine scares, through equipment failures, they got them there. When the sections arrived at forward bases, the real work began. Assembling an ABSD was like building a ship at sea. Salvage vessels and repair ships would maneuver the sections into position. They'd connect them using massive steel pins and locking mechanisms. Divers would go down to inspect the underwater connections. Welders would seal the joints. It took days, sometimes weeks, depending on the conditions. But once it was done, you had something magical. A fully functional dry dock sitting in a lagoon thousands of miles from the nearest permanent naval base. The first major ABSD installation went operational at Espiritu Santo in the New Hebrides in late 1943. By early 1944, there were ABSDs at Manus Island, Eniwetok, and Ulithi. Ulithi, in particular, became legendary. It was a massive atoll in the Caroline Islands. captured from the Japanese in September 1944, and the U.S. Navy turned it into the largest forward operating base in history. At its peak, Ulithi hosted over 600 ships. There were fuel depots, ammunition dumps, repair facilities, and multiple ABSDs. One sailor who served there described it as a city that floated. Another called it the most important piece of real estate nobody's ever heard of. Ships would come in damaged bomb hits, torpedo strikes, collision damage, and they'd go into an ABSD. Crews would swarm over them, welders, fitters, electricians, damage control specialists. Work went on 24 hours a day. Shifts rotated. Arc welders lit up the night. The sound of pneumatic hammers and cutting torches echoed across the lagoon, and ships that should have been out of action for months were back in the fight in days. Let me give you an example of what this meant in practice. November 1944. The Battle of Leyte Gulf. The heavy cruiser USS Canberra takes a torpedo from a Japanese submarine. The hit tears open her hull, floods multiple compartments. She's dead in the water, listing taking on water fast. Normally, that's it. She's done. You either sink her yourself to keep her from being captured, or you somehow tow her all the way back to Pearl Harbor, a journey that would take weeks and require an escort fleet that the Navy can't spare. But this is 1944, and there's an ABSD at Ulithi. They rig emergency pumps, they get her stable enough to tow, and they bring her to Ulithi, 300 miles away. She arrives on October 27th, goes straight into ABSD-2. The damage is catastrophic. The torpedo blew a hole in her hull 20 feet across. Bulkheads are buckled, frames are twisted. Under normal circumstances, this is months of work. The repair crews go to work. They cut away the damaged plating. They fabricate new steel sections on site. They weld in new frames. They rebuild bulkheads. They test every seal, every compartment. Canberra leaves the dry dock on December 17th, less than 2 months from torpedo hit to combat ready. She rejoins the fleet and fights for the rest of the war. That's what the ABSD made possible. The Japanese couldn't do this. Their nearest major dry dock facilities were at Yokosuka, Kure, and Sasebo, all in the Japanese home islands. If a ship got damaged in the South Pacific, it had to make it all the way back to Japan. Thousands of miles. Through waters increasingly dominated by American submarines. Many didn't make it. Even the ones that did often spent months in repair. Because Japanese shipyards were also building new ships, maintaining existing ones, dealing with bomb damage from American air raids. There's a story about the battleship Musashi, one of the 2 largest battleships ever built. She took torpedo and bomb hits at the Battle of Leyte Gulf, survived the initial damage, limped toward port. But there was no forward repair facility. She had to try to make it all the way back to Japan. She didn't. American aircraft found her again, hit her with more torpedoes, more bombs. She sank with over 1,000 men aboard. A Japanese naval officer who survived the war later wrote, "If we had possessed the floating dry docks of the Americans, Musashi might have been saved, but we did not." And so she died. Here's what the ABSD really represented: logistics as a weapon. The Pacific War wasn't just about who had bigger guns or better aircraft. It was about who could sustain operations 5,000 miles from home. And the ABSD gave America something unprecedented: the ability to operate as if they had major naval bases anywhere they wanted them. Damaged ship. No problem. Into the ABSD, fixed in days or weeks instead of months. This meant American ships spent more time fighting and less time in transit. It meant fleet commanders could take calculated risks, knowing that even serious damage wasn't a death sentence. It fundamentally changed the calculus of naval warfare. One American admiral put it bluntly, "With the ABSD, we can stay forward. Without it, we'd have to retreat every time someone got hit hard." The difference between those two realities is the difference between winning and losing this war. The numbers back him up. In 1944 alone, ABSD facilities in the Pacific repaired over 300 ships, everything from small patrol craft to battleships, torpedo damage, bomb damage, collision damage, structural failures. If those ships had to return to Pearl Harbor or the West Coast, you're talking about thousands of days of transit time, months of lost combat capability. The ABSD didn't just save time, it saved the operational tempo that allowed America to keep pushing west, keep taking islands, keep strangling Japan's supply lines. The engineering challenges didn't stop once the ABSDs were operational. These things had to work in conditions that would break a normal dry dock: tropical heat, saltwater corrosion, storms, and they were sitting targets for enemy attack. The sections had to be maintained constantly. Pumps had to be serviced. Steel had to be repainted to prevent rust. Ballast systems had to be tested and retested, and they were operating in combat zones. Ulithi got attacked by kamikazes. Manus took occasional air raids. The men working in the ABSDs knew that at any moment a Japanese aircraft or submarine might show up. There's an account from March 1945, Ulithi Atoll. A kamikaze breaks through the defenses. It's heading straight for ABSD-6, which has the carrier USS Randolph inside it undergoing repairs. Gunners on nearby ships open fire. Tracers light up the sky. The kamikaze takes hits but keeps coming. At the last second, it veers off, crashes into the water 50 yards from the dry dock. The explosion sends up a water spout that drenches the workers on Randolph's deck. But the dock holds. The ship is fine. Work resumes 10 minutes later. One of the welders working on Randolph later said, "We didn't even stop for lunch. The war didn't pause for us, so we didn't pause for it." That was the mentality. These men knew what they were doing mattered. Every hour a ship was out of commission was an hour it couldn't protect the fleet, couldn't support amphibious landings, couldn't hunt submarines. So they worked, in the heat, under the threat of attack, exhausted, dirty, pushing through 12 and 16-hour shifts, and they kept the fleet moving. Let's talk about scale for a second. By the end of World War II, the U.S. Navy had built and deployed dozens of sectional docks of various sizes. The big ones, the ABSD-1 through ABSD-7, were the flagships, but there were also smaller versions. The AFDB Advance Base Floating Drydock series was designed for destroyers and smaller vessels. All told, American shipyards produced enough floating drydock capacity to service dozens of ships simultaneously across the Pacific. That's not just impressive, it's staggering. Consider what it took. Thousands of tons of steel, miles of piping, pumps, valves, electrical systems, all fabricated, assembled, transported, and installed, while the country was also building hundreds of warships, thousands of aircraft, and supporting 2 separate theaters of war. A German naval engineer after the war was shown documentation of the ABSD program. He studied it for a long time. Finally, he said, "We built submarines in sections and assembled them. But this floating dry dock that can be moved anywhere, this is beyond what we thought possible." And here's the thing. The ABSD wasn't flashy. It didn't win battles directly. It never fired a shot. But it enabled everything else. It meant American carriers could stay on station longer. It meant battleships could provide shore bombardment without worrying as much about damage. It meant destroyer screens could be aggressive because even serious damage wasn't the end. Logistics doesn't make headlines, but it wins wars. After the war, most of the ABSDs were towed back to the United States. Some were kept in service. ABSD-1 ended up at Guam, where it's still in operation today, over 80 years later, still lifting ships, still doing the job it was designed for. Others were sold off, converted to civilian use, or scrapped, but their legacy lived on. The modular construction concept influenced everything from offshore oil platforms to modern floating dry docks. The idea that you could build massive structures in sections, transport them, and assemble them. On-site became standard practice, and in the Navy, the ABSD became legend. There's a tradition at naval engineering schools. When they're teaching about logistics and operational reach, they show pictures of the ABSD. And they tell the story of how a bunch of engineers and welders built something impossible. One retired admiral speaking at a ceremony commemorating the ABSD program put it this way: "We talk about the carriers, the battleships, the submarines. We celebrate the admirals and the pilots and the sailors who fought, and we should. But wars aren't won by weapons alone. They're won by the ability to keep those weapons in the fight. The ABSD did that. It's not glamorous, but it might be the most important weapon we had." There's a photo from 1945 that captures the whole thing perfectly. Ulithi Atoll, ABSD-2. The battleship USS Pennsylvania is sitting in the dock, her massive hull exposed. Work lights illuminate welders cutting away damaged steel. Around the dry dock, the lagoon is crowded with ships, carriers, cruisers, destroyers, supply vessels. They're all staged for the invasion of Okinawa. Pennsylvania took a torpedo. Should have been out of the war. Instead, she's here getting fixed while the fleet assembles around her. In the photo, you can see sailors standing on Pennsylvania's deck, looking down at the workers below. One of them later wrote home about it. "They worked all night fixing our ship, never complained, never stopped. I don't know their names, but they saved us. We were back in the fight because of them." That's the story of the ABSD, not the story of admirals or battles or grand strategy. The story of engineers who solved an impossible problem. Of tugboat crews who towed giant steel boxes across oceans. Of welders and fitters who worked in tropical heat to keep the fleet operational. The story of people who built a factory that floated, and in doing so gave America the ability to fight a war on the other side of the world without ever retreating. If you want to understand American power in World War II, you can look at the carriers and the bombers and the tanks. But if you want to understand why America won, look at the ABSD. Because Japan could build battleships, they could train pilots, they could fight like hell, but they couldn't project logistical capability 5,000 miles from home. They couldn't repair major damage in forward positions. They couldn't turn a lagoon in the middle of nowhere into a fully functional naval base. America could and did. The ABSD wasn't just engineering, it was a statement. It said, "We're not playing defense. We're bringing the war to you, and no matter how hard you hit us, we'll fix our ships faster than you can sink them." One Japanese naval officer in his memoirs wrote about the moment he understood Japan had lost the war. It wasn't at Midway. It wasn't when the B-29s started appearing. It was when he saw reconnaissance photos of Ulithi. The photos showed dozens of American ships, and in the center, clearly visible, a massive floating dry dock with a battleship inside it. He wrote, In that moment, I understood we were not fighting an enemy. We were fighting a force of nature. They had made the ocean itself into their shipyard. That's what American engineers did. They looked at the Pacific, the largest ocean on Earth, thousands of miles of open water, and they said, "We're going to build repair facilities out there." And they did. They built factories that floated. They towed them across oceans. They assembled them under enemy fire. And they used them to keep a fleet in the fight for 3.5 years of brutal combat. It shouldn't have been possible. But that's the thing about American engineering in World War II. Impossible was just the starting point. Today, if you visit Guam, you can still see ABSD-1. It's weathered, it's old, but it's still working, still lifting ships, still doing its job, more than 8 decades after it was built. That dock has seen destroyers and cruisers and carriers. It's outlasted the war it was built for. It's outlasted the Cold War. It's still here. And when you look at it, this massive, floating structure sitting quietly in the harbor, it's easy to forget what it represents. It's not just a piece of equipment. It's a reminder. A reminder that sometimes the most important victories don't happen in battles. They happen in engineering offices and shipyards, and on the decks of tugboats crossing the Pacific. They happen when someone looks at an impossible problem and says, "I know how we can do this." The men who built the ABSD, who towed it, who assembled it, who worked in it, most of them never got medals. Most of them never got famous. But they won the war. Not with guns, not with ships, but with the quiet, unglamorous work of keeping the fleet operational. That's the legacy of the ABSD. American engineers did the impossible. They built a factory that floated, and it changed everything.